Good afternoon, everyone. So my presentation is about, the title is Towards an Arctic Atlas of Unburnable Carbon, Mapping Oil and Gas Extraction, Biodiversity, Indigenous Lens under a Climate Justice Lens. So the framework, the basis of this research was that if you want to have some chance to stay under the famous target of 1.5 degrees of temperature, we have a carbon budget calculated in 2021 of about 500 gigatons of CO2, so the carbon budget in the atmosphere. But for example, McRae and Atkins in 2015 calculate that underground we had 11,000 gigatons of CO2, so a lot compared to the carbon budget for the atmosphere. So here the idea of unburnable carbon, the idea that we have to keep underground a huge amount of coal, gas, and oil. Okay, and in particular, the Welsh et al. Set some target for the oil and gas. So 90% of coal and 60% of oil and gas should keep underground if you want to have some chance to respect this target. But we, as geographer, our mainly question is where. So we want to, we are investigating in the Center of Excellence the geographical perspective of this, where to keep oil and gas underground, okay? Because also, moreover, the climate change aspect, we know that there are a lot of direct and indirect socio-environmental impacts of oil and gas activities, deforestation, gaseous emission, noise and vibration, oil spills, and so on. So it's all about the places and spaces, okay? And in this case, for this study case, we selected the Arctic region as a case study, okay? In particular, the CAF boundaries. There are different, several boundaries for the Arctic region. We select these CAF boundaries that comprise climate and biogeographical criteria, okay? Because Arctic is very fragile, and also Wellesby also said that all Arctic oil and gas resources should remain unextracted. So the all Arctic resources should be unburnable, but Arctic oil production is about 5.5% of the global production, and also it is expected to further increase in the next year. So as you can see, there is a mismatch between the research and the reality. In this case, for our investigation in this presentation, we, of course, we have to know what happened in Arctic. So we started from the creation of Atlas of Oil, Gas Production and Exploration of the Arctic region, okay? And we try to estimate the spatial relationship between this oil and gas dimension and with biodiversity protection and indigenous people lens, okay? This is so would be the basis towards a spatial matrix criteria analysis based on different geographic criteria to define where to leave fossil fuel underground in the Arctic region, thinking that exploitation is going on and probably will increase in the future. Okay, the workflow. So for this research, there was an extensive data mining of open spatial data from a government, geospatial, geoportal, company website, and from civil society. And then all these data, this information were analyzed in QGIS environment, so in JS environment, with different overlap and distance analysis. Here, this is the overall workflow of this investigation. Some results. And we have these are the maps that we produced about, so the maps of the overall CAF Arctic area. Okay, so we have in this area we have some portion of Alaska, Canada, Greenland, Norway, and the Russia Federation, as you can see. In this case, we have that the exploited areas, okay, that are these in brown mainly, so exploration and production areas, cover a territory comparable of European France, okay? And we have that the pipelines, so the mean where the oil and gas will is transported from the production area is more than 6 times the Earth radius, and also the seismic lines that are lines that seismic lines are used to for exploration purposes are 5.5 times the Earth-Moon distance. Okay, so here you can see the spatial distribution of all these features. Oil and gas wells, okay, we have more than 44,000 wells, mainly located in Canada, here in the British Columbia and Alberta provinces, and onshore and offshore, mainly in Norway, okay, as you can see here in this map. The relationship with, for example, protected areas, even if at the level of all Arctic region, the overlap is only is the 7%. Okay, as you can see, if we focus on some areas, as you can see, there are several protected areas that are rounded by different oil and gas infrastructures, and also within and inside and also outside. So we have a lot of different infrastructures, okay, as you can see here in Canada and in Alaska. And related to indigenous land, that is in this orange color, okay, these are all the indigenous formally and not formally recognized by the different countries. We have that the concessions cover more than 4% of these lands, but as you can see, the 73% of all concessions are located within the Arctic indigenous lands. Okay, so there is a very there are a very high relationship between indigenous and oil and gas activities. Some conclusion. So data challenges, of course, here the main challenge that we found in this, but also in the other area that we are investigating, Amazon region and so on, is the data heterogeneity. And in this case, among all the other countries, Russia, of course, is the most challenges to find mainly oil and gas information for Russia is now very, very hard. Okay, so this is one of the main challenges of this work. The need for a multi-scale approach, okay, because we say that there are different situations at different geographical scale. And then on the basis of all this information, we want to also define criteria for the multi-criteria analysis. This criteria, we would like to define these criteria and their weighting with a participatory process approach. Okay, and also there are a lot of very rapid changes in these areas. So for example, the concession area and so on can vary year after year. So this is also another issue that we have to take in account. Future perspectives. So the idea is to try to create some simulation of multi-criteria, spatial multi-criteria analysis at different scales, at CAF scale, but also national, some national scales, to include the time factor in this analysis, and try to collect other spatial data with different effort, also involving maybe local institutions and local NGOs. Thank you.